Chapter 11 was a mini chapter on rational numbers. A rational number is a number that can be written as a ratio of integers. Quick reminder, integers are counting numbers, positive and negative, and that includes 0. So a ratio is a fraction. So essentially, rational numbers can be written as fractions or decimals, as long as they're decimals that either repeat or end. But the real key here is to know the definition that it's a ratio of integers. That's what you want to use in your explanations when you're answering questions on the Regents exam. There's all sorts of rules for rational numbers. Anytime you have two rational numbers, whether you're adding, subtracting, multiplying, or dividing, you're always going to get a rational number as your answer. If you have one of each, meaning you have your rational and an irrational, whether you're adding, subtracting, multiplying, or dividing, you're always going to get an irrational number. If you have two irrationals, there are no rules for that, which means you need to actually solve the problem out and then figure out, is your solution either rational or irrational? So there's no shortcut when you have two irrational numbers. But if you know these rules, you can use them as part of your justification or your explanations in questions. Okay, so let's look at an example here. The first one says, state whether 7 minus the square root of 2 is rational or irrational. Explain your answer. There's two routes you can take, and I'm going to kind of give you two different options for how you could answer this and get complete credit for this. So the first route is to use the rule. So first you would indicate what each number is. So 7 is a rational number because it could be written as a fraction, 7 over 1. Square root of 2 is an irrational number. Anytime you take the square root of a non-perfect square, it's always going to be irrational. So if you indicate what each number is and then use your rule, rational minus irrational is equal to irrational, that would be enough of an explanation to get you full credit. Your other option would be to do into your calculator 7 minus the square root of 2, which equals 5.5857864, and it keeps going and going. So now we're going to be looking at this number here, and we need to decide if that's rational or irrational. This decimal does not end and it does not repeat, therefore it could not be written as a ratio of integers, and that's going to make it irrational. So we would write irrational because this number right here cannot be written as a ratio of integers. So either method you use for an explanation here is fine, as long as you have each part of it. On the left side, you have to name each piece and use the rule, or on the right side, you would need to name it and then use the definition as an explanation of why it's rational or irrational. Either way works, whichever one you prefer. Okay, so let's look at the next example. Determine if the product of 3 square roots of 2 and 8 square roots of 18 is rational or irrational. Explain your answer. So let's go through piece by piece. 3 square roots of 2, that's going to be an irrational number because the square root of 2 is not a perfect square. 8 square roots of 18 is also going to be an irrational number because 18 is not a perfect square. And we have to do the product, which means multiplication. Now, anytime you have two irrationals, there is actually no rule. There's no shortcut for this. So we actually need to do the problem out and then determine if it's rational or irrational. So method number 1 that you see above is not going to work because there is no rule that we can use. So we have to revert to option number 2. So we have 3 square roots of 2 times 8 square roots of 18. When you're multiplying radicals, you multiply the coefficients. So we get 3 times 8. And then you multiply the radicands, so you get 2 times, or square root of 2 times the square root of 18. 3 times 8 is 24. Square root of 2 times square root of 18 would be square root of 36. So we get 24, and then the square root of 36 is 6. 24 times 6 is 144. So now we're using this number to decide if that's rational or irrational. 144 is rational because 144 can be written as a ratio of integers. 144 could be written as 144 over 1, which would make that a ratio. So the answer would be rational number. So when you have two irrationals, the reason why there's no rule is because sometimes it will end up being rational, sometimes it will end up being irrational. So you just need to make sure that you don't make up a rule there. You would just need to do the problem out and then prove it using that definition. If you can get these types of problems down, there is always at least one. Sometimes it's a short answer, sometimes it's a multiple choice type of question like this. So if you can get this down, that is 2 points that you can guarantee for yourself.